Objective 3 of Practice Test B has us identify and use the limiting reagent in a reaction to calculate the maximum yield of product produced and the amount of excess reagent left unused at the end of the experiment. Our first equation has us reacting magnesium with iron 3 bromide in a single replacement reaction. Magnesium is written by its symbol Mg. Reacting with iron, the Roman numeral tells me +3. Bromide, who carries a -1, so FeBr3. Single displacement will tell me magnesium will kick out the iron, leaving iron now by itself, and grabbing onto the bromide, but hooking by charge. Magnesium, who carries a +2, bromide, who's still a -1, I crisscross, I get MgBr2. With that reaction, we'll need to balance the bromines. We have 2 on the right and 3 on the left, so we'll need to turn them both into 6s. So I'll place a 3 in front of the coefficient there at magnesium bromide, and a 2 in front of the reactant iron bromide, repairing the magnesium with a 3 and the iron with a 2. A 3 to 2 to 2 to 3 stoichiometric ratio. When we look at letter B, it reads, how many grams of magnesium bromide, so our target product, magnesium bromide, can be produced by the reaction of 332 grams of FeBr3, iron 3 bromide, and 403 grams of magnesium. We're given information about both reactants and a target product, magnesium bromide. We'll need to do 2 separate problems, finding the maximum yield as the smaller of our 2 answers. I'll get my parentheses ready so we can see the journey, divide, ratio, multiply, the target being grams of the product, MgBr2. Same 3 steps down below for the magnesium. Same target, MgBr2 grams. When we begin with 332 grams of iron 3 bromide, our first parenthesis will require its molar mass. Let me add for that. 55.8 for iron. Bromine is 80, but there's 3 of them. 55.8 plus 80 times 3. I get 295.8 grams of iron 3 bromide. And that will sit under 1 mole of FeBr3. In the heart of our problem, we'll need a stoichiometric ratio of want over given. We want to know magnesium bromide, its coefficient is 3. Starting from FeBr3, its coefficient is a 2. So we have a 3 over 2 stoichiometric ratio. In the last step, we'll need grams of magnesium bromide. Magnesium is 24.3 plus 80 times 2 for the bromine. This gives us 184.3 grams as our molar mass of our product, MgBr2, set over 1 mole of MgBr2. We'll start with our 332. I'll divide by 295.8. I'll now multiply by 3 and divide by 2. And the last step says multiply by 184.3. This gives me an answer of 310.3 grams of magnesium bromide. We'll now start the same problem targeting magnesium bromide, but from the first reactant, magnesium. In our first conversion, 1 mole of Mg set over its molar mass, 24.3 grams. Same target product, its mole number was 3 moles of MgBr2. Coefficient for this reactant is also a 3 moles of Mg. Our third step will be identical to the problem above. 184.3 grams is the molar mass in every 1 mole of MgBr2. We'll start with 403. I'll divide by 24.3 times 3 over 3, I'll just ignore, times 184.3. divided by 24.3 is 184.3. I got a big number. I hope that's right. 3056.5. That's very clear which one is the smaller of the two. I'm going to circle the 310.3 and label that as my maximum yield of product. I also want you to come back and label for me that you know the iron bromide was called the limiting reagent, and also label for us that magnesium was the excess reagent. We'll include all of that information in our answer, and it helps me go on to letter C as we predict how many grams are left over of the excess reagent. If the magnesium is the excess, that becomes the target we need for part C. When we determine the grams of excess reagent left over, we start the problem, as always, with the limiting reagent, 332 grams of FeBr3. Start with the limiting, and we want to target the excess reagent. I like to target that in the same unit it was given so that we can subtract like units. The excess reagent was reported in a gram. Let's make that our target, mg. That way when we find how many grams were used, we can subtract it from the 403 we started with. So start from the limiting and go to the excess, the 3 steps to stoichiometry. Borrowing our molar mass we calculated a moment ago for FeBr3, we found it to be 295.8 grams. So that was the same first parenthesis from up above. We want over given in the heart of our problem, we want the excess from the limiting. So when I place my want over given ratio, we place 3 moles of Mg over 2 moles of FeBr3. The last step, we'll use our molar mass of magnesium, 24.3 grams in every 1 mole of magnesium. Divide, ratio, multiply. Start from the limiting and head to the excess. 332 divided by 295.8 times 3 divided by 2. And the last thing is times 24.3. I found 40.91 grams of magnesium. This is